Alright, welcome to our probability unit. I'm your professor, Tyson Beggs. This slideshow can be found in Angel. Go ahead and download it. We'll walk through it together. This is just an introduction to probability. A couple of things we need to do first. We need to define a couple key vocabulary words so that when we're going through this, you know what we're talking about. Alright, so the first one we're going to do is experiment. An experiment is just like when you're in science class and you went on and you did something. When you do that thing, whatever it is, you get results. Those results are called our outcomes in probability. So if we're flipping the coin is actually the experiment. The outcomes would be what happened. Did you get a head or did you get a tail? Then the collection of all those outcomes are called your sample space. When you do experiments, you do, maybe flipping a coin, you're going to flip it multiple times, so you're going to have several things in this sample space. Alright. Here's a chart with some of the possible experiments you can do. Tossing a coin, rolling a dice, tossing a coin twice, playing the lotto, taking a test, selecting a worker, male or female. Okay, so your outcomes, we'll look at the coin, it's a head or a tail. In your sample space is equal to head or a tail. There's two possible outcomes, head or tail. So if you go to toss a coin twice, your outcomes could be head, 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 tail, tail, head, or tail, tail. So there's four different things in your sample space. All your four outcomes are right here. So I hope this helps you realize what these words are because we're using them a lot. Next thing we're going to talk about is an event. An event is a collection of one or more of the outcomes of the experiment. So one or more of the outcomes of the experiment make an event. We got different types of event. We got a simple event. That is one and only one of the final outcomes. So simple, it's you were tossing a coin twice, you got two heads. That would be simple event because there's only one of those as a possible outcome of getting two heads. Compound event is a collection of more than one outcome. So your compound event is the probability of getting exactly one tail. Well, you can get a head, then a tail, or you can get a tail, then a head, but you still got exactly one tail. So what we're going to do now, we're going to work through this example. It's about students in your class on the ISAT. They either pass or they fail. So what we're going to do is we're going to set up and we're going to answer 3 questions down here. And during this, just keep thinking to yourself, is this simple or is this compound? We want to know if it's a simple event or a compound event. So both students passed the ISAT. That's question 1. Is that simple or compound? How do we know? B is at most one student failed the ISAT. And then C is exactly one student failed the ISAT. So we're going to work through this. We got our labels here. F is going to be people who failed. A is going to be assigned to those who passed. FF, both students passed. FA, the first student passed, the second student failed. AF, it's first person passed, second failed. AA, down at the bottom, is both students passed. So you'll want to write those down. If I'm going too fast for you guys, you can hit pause, you can catch up on the PowerPoint so you see what's going on. But we're just going over this, and this is here for you on Angel, so don't feel like you have to write everything down. Alright, so when you're organizing your probability, you can do a tree diagram, which is here, or you can do a Venn diagram. I prefer the tree diagram. Tree diagrams, in my opinion, help really organize stuff and keep things where you can see them pretty well. Venn diagrams are alright, they're not bad. This is your sample space here. Your possible outcomes are first person failed, second person failed. First person passed, second person failed. First person failed, second person passed, and then both people passed. The tree diagram is really similar to that. We look at the first person, that's the first branch on the tree. You either got a pass or a fail, 2 options, and that's going to determine where you go on your tree. If the first person failed, you go up this branch, up the F branch, and then you go to the second person. Did they fail or did they pass the ISAT? Okay, so if the first person failed, the second person failed, your outcome would be FF. First person failed, second person passed, it's FA. Do the same thing on the bottom branch, and this is all your possible outcomes over here. Alright, so back to our question now, is both students failed the test? Well, there was only one thing. If we look at the tree diagram, they go up the fail branch and then they go up the fail branch again. So both people failed. That would be what we call a simple event. There's only one of those outcomes. There's only one outcome where both people failed. So let's go to B, where it says at most one student failed the ISAT. Alright, so this could mean a couple things. At most one student failed the ISAT. So it can mean no students failed the ISAT. Could mean the first person failed the ISAT but the second passed, or it could mean the first person passed and the second one failed. Those are all possible outcomes for at most one student failed the ISAT. Okay, this would be what we want to call a compound event. There's different outcomes, there's more than one outcome. That would be a compound event. If we look at the last one, exactly one person failed the ISAT. So the difference between this one, B and C, is the at most versus exactly. Exactly is equal. So only one person failed it. So either the first person failed it or the second person failed it. But realize this is still a compound event because we got two possible outcomes over here, FA and AF. Okay, I hope that helps you see the difference between simple and compound. You got a couple homework problems on simple and compound. If you have questions, feel free to ask me. Some of them make you think a little bit, but really just remember how many possible outcomes we have. A simple event has one possible outcome. Compound events have more than one possible outcome. Alright, definition of probability. Probability is a numerical measure of the likelihood of something happening, a specific event happening. The probability of flipping a head when you flip a coin. There's one chance of getting ahead out of two total, mine went blank there, but you got a head and you got a tail. So you flip the coin, chance of getting ahead is 1 out of 2. Alright, so we got here probability of an event always lies between 0 and 1. This is important. Probability is always going to be a decimal or a fraction between 0 and 1. It's not going to be negative. It's going to be between 0 and 1. So your first property of probability, it talks about the experiment is always between 0 and 1. And then it talks about the actual probability being between 0 and 1. Things you need to know, experimental probability is you go out, you do the experiment, you get outcomes, you get a probability. Actual probability is what we call theoretical probability. It's where, in theory, this will happen. I flip a coin, 50% of the time I'm going to get a head, 50% of the time I'm going to get a tail. That's in theory. Actuality might not be the same. Okay, and then the second property of probability is for experimental probability. It says your experiments, experiment 1, experiment 2, experiment 3, the probability of all those happening and their outcomes will add up to 1 every time. So you're rolling a dice, probability of getting a 1 is 1/6, probably getting a 2 is 1/6, 3, 1/6, 4 is 1/6, 5 is 1/6, 6 is 1/6. You add all those up, you're going to get 1 out. So the sum of all your probabilities is always going to add up to 1. Alright, back to that real fast. That's really important to know when you're doing probability. If you don't have it add up to 1, you know you did something wrong. Go check your work, try to see if you left something out. But that second property is very important because if it adds up to 1, you did it right. If it doesn't, you need to check your work. Alright, we got classical probability. 2 or more outcomes or events that have the same probability of occurrence are said to be equally likely outcomes. Equally likely. We use that word because it's equally by chance it could happen. It doesn't mean it will happen equally, but by chance, equally likely outcomes. Alright, flipping a coin. Back to that. It's equally likely that you'll get a head and you'll get a tail. We got right here, we got 1 divided by the total number of outcomes for the experiment. Okay, rolling a dice. You got 1 chance of getting a 1 out of 6 possible outcomes. That would be the probability, 1 out of 6. Your other one is when you go out, the number of outcomes favorable to A. So you pick A, let's say it's a 2 on the dice, versus the total number of outcomes for the experiment. So you did the experiment, you rolled the dice 12 times, you got 3 2s. it'd be 3 out of 12. That would be your experimental probability. This would be your theoretical, this would be experimental. You go do it, count up the number of times that happened, divide it by the number of times you rolled the dice, you flipped the coin. Alright, so we want to find the probability of attaining a head and the probability of obtaining a tail for one toss of a coin. We've talked about this several times. One head, total number of outcomes, 2, 50%. So the probability of a tail is 1 out of 2, or 0.5. The reason I show you this slide, even though we talked about it a lot, is this breaks it down, shows you one possible head out of 2 possible outcomes, 1 out of 2. And notice they write it as 0.5, they write it as a decimal. Same thing down here. Look down here, it says probability of a tail. You're going to see notation a lot, probability of a head. It's always what's in here is what we're looking for. Alright? Now we got relative frequency concept of probability. This is where we go out and we do an experiment. We go out, like I was talking on that one, where you roll the dice 12 times, you get 3 of them are 2s. That would be what this is talking about right here. The probability of A occurring, whatever A is, if that's what you're trying to find, is equal to how often A happens divided by how many total times we did the experiment. So if we were back to that 3 2s, 12 total times, our probability would be 3 divided by 12. Okay? So then you can take your 3 divided by 12 and turn it into a decimal by taking on your calculator 3 divided by 12. Or you'd know that would be 0.25. So you got a 25% chance of that happening. That's what frequency is. You go to the experiments, how many times did your outcome happen? Alright, definition of large numbers. Okay, so this is our law. It's if you do these experiments over and over and over and over and over and over, your experimental probability and your theoretical probability will become equal, is what it's actually saying. Or they will approach each other. They'll never actually get 100% equal, but they will approach each other. And the reason for that is when you do an experiment, you could have random outcomes. You can't control those outcomes. So it won't always be the same as your theoretical probability, but the more you do, the closer they come to each other. And the last one is subjective probability. The definition of subjective probability is a probability assigned to an event based on subjective judgment, experience, information, and belief. Okay? This is where you don't use this a lot in probability, but my experience is 5 out of 10 people drive black cars. It's just my experiment. It's not true, but based on my experience, that's what I saw. That's what I came up with. You won't use this one nearly as much as you'll use the other one, but it's still important to know the difference. Alright, I really hope this helps you. This is a quick little bit of probability. I'll have this posted on Angel, this PowerPoint, so that you can follow it. If you have any questions, email me at any time, and we will go through these together. Thank you guys very much.